Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the object oriented module, and in the today's class I am starting your new chapter, that is chapter number 9, that is pointers, virtual functions and the polymorphism. But before that, let's take a quick review what we have covered in the last class. That is we have finished in the last class, that is chapter number 8. So we have finished the chapter, that is the chapter inheritance, that is what is inheritance and what are the various types of inheritance, how to use the constructors in the derived class, and so many things in the chapter number 8. And this is a full long chapter, lengthy chapter that is covered in the last class. So let's continue with the last class session, then moves to the today's class, that is the today's topic, that is chapter number 9, that is pointers, or what is the pointer, what is virtual function, and what is the polymorphism in the C++, or how to use the polymorphism in C++, right? So let's start with the constructors in the derived class or last class topic. So as we know, the constructor plays an important role in initializing the objects. We do not see them earlier in the derived classes for the sake of simplicity. That is, we have not used the constructors in any of the class, in any of the object that is taken away. So we cannot, or we do not, or we did not use them earlier in the derived classes for the sake of the simplicity, so that the program becomes simple. One important thing that is noted down, that there is no base class constructor that takes any argument. The derived class needs not have a constructor function. So there is no constructor function, there is no derived class constructor function that takes place or that takes any argument. However, if any base class contains a constructor with one or more argument, then it is mandatory for the derived class to have a constructor and pass the argument to the base class constructor. So if a base class have any a conductor, or with one or more argument has a constructor, then it is mandatory for the derived class to have a constructor that will pass the, or that should pass the argument, that is used to pass the argument to the base class constructors. In case of multiple inheritance, the base classes are also constructed in the order in which they appear in the declaration of the derived class. So that is the same, that is declared, that is constructed in the same order in which they are declared in the form of inheritance. The constructors of the derived class receives the entire list of values as its argument. So the constructors of the derived class that is given, that is taken, that is receives, or that is taking the values of the entire list of values as its argument and passes them on to the base constructor. Then we have studied about how to, or what is the general form that is used to define a derived constructor. This is the derived constructor general form, that is derived constructor argument 1, argument 2, argument list 2, argument list n. So there are multiple argument lists that is available. Then there is a base 1, that is argument list 1, then base 2, then argument list 2, then base n, that is the argument for the base n. So there are various argument that is used. There are various categories of argument that is used, that is the various argument types. Then there is a body of the derived constructor, that is what is the derived constructor, how it is used. The header line of derived constructor function contains two parts, that is separated by the colon. The first part provides the declaration of the argument that are passed to the derived constructor, and the second part lists the function calls to the base constructor. So there are various constructors, there are various parts, there are various functions that is called, that is used as a function calling. Base 1, argument list 1, base 2, argument list 2 are the function calls to the base constructors. Base 1, base 2 and therefore argument list represent the actual parameter, that is base 1, base 2, argument list 1, argument list n are the various argument declaration that is used for the base classes that is derived for the different classes. This is a general form. Then we have studied about the example, that is how to use the constructors in the derived class, and these are the various example, that is how to use the object or how to derive the object that is taken for to use in the constructor class, that is the object ABC or object A to Z. So these values are assigned as a various parameter to various parameter by the constructor D as follows. So what are the various ways? These are the various ways by which that constructors will be used. these are the various methods of inheritance, that is how to use the inheritance, and these are the various order of execution, that is what is the main order or what is the order of the execution, how to execute them and how to make them how to make them in the attractive class or how to make them in the inherited class. This is the method that is used. There is a class B, then there is a colon, then there is a public A, then class A, then public B, public C, then class A, public B, then there is a virtual public C. So these are the various methods of inheritance, and there are various orders of inheritance that is used. Then we have studied about the example that I'm going to discuss in a practical way in the today's class only. So we are going to cover in the after the break, that is the after the tea break or after the small break. Then we are discuss about how to use the member classes, or what is the member classes, that is the nesting of the classes, that is one class within another class, that is a nesting of different classes. So that is known as the member classes. So this is the mechanism of deriving certain properties of one class into another class, that is how to use one class into another class. And C++ also supports of inherit the properties of one class into the another, that is how to take the or how to support the inheritance properties or inherited property that takes place in the form of another or into another. This approach takes a view that an object can be a collection of many other objects. That is, a class can contain objects of other classes as its members as shown below. So these are the various classes. Then there is a class alpha, there is a class beta, there is a class gamma. All the objects of gamma class would contain the objects A and the B. So these are the various objects that is declared. There is a alpha A, there is a beta B. So these are the various objects that is taken away. This kind of relationship is known as the nesting of member functions, or nesting of different classes, or nesting of classes. So that is known as the nesting of classes. That is how to represent or how to use the nesting classes. Creation of an object that contains another object is very different than the creation of an independent object. This is example, that is how to use the constructor classes, or how various arguments are defined, or how to initialize the members of the gamma. Then we have studied about the summary, that is how to use the summary, or what is the summary of this chapter, that is how to discuss this chapter, or what is the logic behind this chapter. So this is a summary that we have discussed, that is what is the inheritance, what are the various functions that is used in this inheritance. Then there are review questions, that is what are the various or there are various questions that is available for the inheritance, and these are the various debugging exercises, that is finding out the errors in these functions. Then there is identify the error. This is also error based questions. Then there is a programming exercises, that is how to use the program, or this is the programmatical exercises. Now there is a next chapter, that is chapter number 9, that is pointers, virtual functions and the polymorphism. That is how to use the pointers, how to use the virtual function, what is virtual function, and how or what is the polymorphism. So that are the 3 points that is used, that is pointers, virtual functions and the polymorphism. So first of all, there is an introduction, that is what is polymorphism and how this polymorphism will be used. So let's start with chapter number 9, that is the introduction to the polymorphism. So first of all, it says polymorphism is one of the crucial means important as well as the tricky feature that is available of the or that is available in the object oriented programming. So this is one of the crucial feature that is available in the that is available for the OOP, that is the object oriented programming. It simply means one name, multiple forms. That is, there is a single name, but there are multiple forms. For example, the function overloading, that is the best example for the polymorphism. The name of the function is same, but there are multiple forms, that is a polymorphism. As the name advice, poly means more than one, and morphism means using more than one form, that is a polymorphism. So we have already seen the concept of polymorphism, that is implemented using the overloaded functions and operators. The overloaded member functions are selected for invoking by matching arguments, both type and the number. So how the or what is the next question, that is how the overloaded member functions are selected or occupied, that are selected or occupied by invoking the member functions by matching the arguments. What type of argument? Both the type and the number. That is what is the type, that is a data type, and what is the number, or how many number, or how many arguments, or how many variables are declared. That is the overloaded member functions are selected for invoking by matching arguments, both type and the number. This information is known to the compiler at the compile time. This is the information that is given to the compiler at the compile time, that is what are the types of arguments and what are the number of arguments. And thereafter compiler is able to select the appropriate function for a particular call at the compile time itself. So when the compiler decides that which function is used or which appropriate function is used at a compile time, so then it is decided, or then it will be occupied by the, or it is used by the compiler. This is known as the early binding or static binding or static linking. So this is known as the static linking, static binding, or the early binding. Also known as the compile type polymorphism. So whenever there is more than one form that is occupied, that is used at the compile time, that is when the compilation, when the program is converted into bits, at that time if there is a polymorphism, if there is a multiprocessing, multitasking, that is more than one form, that is known as the compile type or compile time polymorphism, or static binding or static linking. Early binding simply means that an object is bound to its function call at a compile time. That is, early binding is also known as that an object is bound to its function call at the compile time. That is, how to use the function call at the compile time. Let us now consider a situation when the function name and the prototype is the same in both the base and the derived classes. There is a class A, then int x, then there is a public. So x is the variable that is declared, that is a data member, that is private by default. Then there is a public, then there is a void show, that is show in the base class. So this is a function that is defined in the base class, that is class A, then class B, and then there is a public A. That means this is a derived class and this is the public A. Then int y, it is a data member that is used. Then public void show, that is used in the derived class. Then there is a scope resolution, closing curly braces, and there is a semicolon. So this is also used in the derived class. That is how it is used in the derived class. So how do we use the member function show to print the values of object of both the classes A and B? So since the prototype of show is the same in both the places, since it is the same in both the places, that is in the base class and the derived class, so the function is not overloaded and therefore static binding does not apply. So it is not overloaded and the static binding is not applied over this. We may use the class resolution operator to specify the class while invoking the functions with the derived class object. So we may use the scope resolution operator to specify the class, that which class or which show function will be used, either from the derived class or either from the base class. So which function will be used at the time of compilation, at the time of runtime or compile time polymorphism, which function is used either from the base class or from the derived class. It will it will be nice if the appropriate member function could be selected while the programming is running. That is which function is used at the compile time. I'm just coming within 2 minutes. So it would be nice if the appropriate function or member function could be selected while the program is running. So if the program is running at that time, the function is running at that time, the function is program is running. That is known as runtime polymorphism. So one is compile time. At the time of compilation, if more than one functions are used at the same time, that is known as compile type polymorphism. And when the program is executing or when the program is running, at that time the function will be selected or the member function could be selected. That is known as the runtime polymorphism. How could it happen? That is, what is the use or what is the method, what is the technology that is used or that is applied to the runtime polymorphism. That mechanism or C++ supports a high level mechanism that is known as the virtual function. So this virtual function should be used to achieve the runtime polymorphism. That is, at the time of runtime it is decided that which function will be used at the current time, that is either the base class function or either the derived class function. This is a polymorphism. There is a compile time polymorphism, there is a runtime polymorphism. There are two types of polymorphism that is used, that is compile time and the runtime. At the compile time there are two functions or there are two parts. One is the function overloading, one is the operator overloading. So when the program is only compiled, then there are two parts or these are of two parts. One is the function overloading, one is the operator overloading. And at the runtime there is only one part, there is only one technology that is used, that is known as the virtual functions. So one is the compile time polymorphism, one is runtime polymorphism, and compile time is occupied by the function overloading and the operator overloading, and the runtime is occupied or solved by using the virtual functions. And virtual function is one of the most important concept that is occupied or that is carried out or that is supplied by the C++ or any object-oriented programming. Right. So let's start with the runtime polymorphism. Let's continue with some theory also. This is at runtime when it is known and that what class objects are under consideration, the appropriate version of the function is invoked. That is, appropriate function is used or appropriate function will be invoked at the time of creating the object. Since the function is linked with a particular class much later after the compilation. So since this function is linked with a particular class, that is how it is used after the compilation. This is known as the late binding. So which function is used or which function is linked with a particular class after the compilation, that process is known as the late binding or the runtime polymorphism. It is also known as dynamic binding because at the time of compilation, at the time of runtime, this dynamic binding will be used or the function will be selected at the time of the runtime. So that's why it is known as the dynamic binding, because the selection of the appropriate function is done dynamically at the runtime. Dynamic binding is one of the powerful features of C++. This is also one of the powerful features, as I said, that is supported or that is achieved by using the virtual function. This requires the use of pointers to the objects. We shall discuss in detail how the object pointers in the virtual functions are used to implement dynamic binding. That is how to use the pointers, how to use the virtual function that is used to implement the dynamic binding. So this is just a theory. We will achieve this theory or we will execute this theory in detail in practical part, but this is just the theory, that is how to use the polymorphism or what are the types of polymorphism or what is polymorphism. Right. Then next is pointers, that is what is the pointers, how the pointers will be used. So this is one of the key aspect of the C++ language that is similar to that of C, that is the pointer, that is very similar to the C language. That is similar to that of C. As we know, pointers offers a unique approach to handle data in both the C and the C++. So we introduce some introduction in the chapter 3 and the 5 also. In this section, we shall discuss the rudiments of pointers and the special uses of them in C++. That is, what is the main target or what is the usage or why we are using the pointers in the C++. A pointer variable defines where to get the values of a specific data variable instead of defining the actual data. Like C, a pointer variable can also refer to another pointer in C++. That is, we can use another pointer or we can use the same pointer in C++ by using the concept of the pointers. However, it often points to a data variable. Pointers also provides an alternative approach to access the data objects. That is how to use the data object or how to access the data object. That is a pointer. Now next is declaring and initializing the pointers. That is how to declare and how to initialize the pointers, or how to use the pointers, or what is the syntax to declare the pointer, initializing the pointers, right? So this is how to declare and how to initialize the pointers. So a pointer variable is similar to other variables in C++. Like C, the declaration is based on the data type of the variable it points to. So it depends on the data type to which it points to, or the location it points to. The declaration of a pointer variable takes the following form. This is the declaration that is used. There is a data type, then there is a asterisk, then there is a pointer variable. That is how to use the data type, or what is the data type that is used, and how to use them in a pointer variable. Here pointer variable is the name of the pointer, and the data type refers to one of the valid C++ data types such as int, char, float, and so on. So pointer variable is the name of the pointer that is used, and data type refers to one of the valid C++ data type, that is either int, float, char, and so on. The data type is followed by an asterisk sign. So whatever the data type that is followed by the asterisk sign, that is a pointer variable, which differentiate a pointer variable from another variable or other variables to the compiler. That is how to use the compiler, or how to use the pointer variable, or how to use them with a separate pointer that is used as a pointer variable. We can locate the asterisk immediately before the pointer variable, or between the data type and the pointer variable. So this is the syntax that is used. There is a data type, for example int, float, char, double, and so on, and any data type that is used, and the pointer variable, that is the name of the pointer that is used, and there is an asterisk sign in between, that is data type and the pointer variable. So we can asterisk, or we can use the asterisk immediately before the pointer variable, or between the data type and the pointer variable, or immediately after the data types. That means this asterisk will be used inside or in between the data type and the pointer variable. First of all, there is a data type, for example int, then there is a asterisk, then there is a, for example, p. So p is a pointer variable that refers to the integer type. I'm repeating again. If I'm declaring int pointer pa, that is data type is int and the pointer variable is pa, and there is a asterisk sign that denotes the pointer. So pa is a pointer variable that refers to some integer value, and this is very important note that it is declared or it is used in between the pointer variable and the data type. This says, as we know, a pointer variable can point to any of the data type or any of the data that is available in C++. It is necessary to understand that a pointer also points to only one data type at the time. So this is the example that is given. The same example, there is an int pointer ptr. Ptr is a pointer variable that points to some integer data type, or that points to some integer value. That is how the integer value will be used. That is known as the pointer data type, or that is known as the ptr. So ptr is a pointer variable that is points to the integer data type. Like any other programming, or like other programming languages, a variable must be initialized before using it in a C++ program. We can initialize a pointer variable as follows. So this is a syntax that is used. There is an int pointer ptr a. This is also a declaration. That is how to use the pointer, that is using the asterisk sign, that is a pointer int pointer ptr. Then ptr equals to ampersand a, that is initialization. That is how to initialize the value, how to denote the value, how to use the ampersand, that is the initialization. The pointer variable ptr contains the address of the variable a. Like C, we use the address of operator or reference operator, that is ampersand, to retrieve the address of a variable. So like C, we can use the address of operator to retrieve the address. As we say, whenever there are both the signs that is used, that is a ampersand and the asterisk, so that will be used to retrieve the value, to retrieve the address of the variable. So this is the pointer that is used. Then this is the second feature that is used, that is the second statement that assigns the address of the variable a to the pointer ptr. So address of A, that is the ampersand A, that address will be assigned to the PTR variable. So ampersand is address of operator that is used to denote the address, or that is used to take the address, that is how to take the address or how to use the address, and that address will be assigned to the pointer PTR. We can also declare a pointer variable to point to another pointer that is similar to that of C. That is, a pointer variable contains address of another pointer. This shows how to use the pointer, that is example of using the pointers. So there is a hash include iostream.h. This is again the same. Then iostream, conio.h. Then there is a void main, that is the starting of the main. Then there is a int a, pointer ptr1, pointer ptr2. So there are two pointers that is initialized, that is ptr1 and the ptr2. And there is simple variable, that is a, that is int a. Then there is a clear screen, that is for clearing the screen. Then ptr equals to ampersand a, that is the address of a will be assigned to the ptr1. And the address of ptr, because pointer is a variable that points to some another, or that points to the address of another variable. So ptr this time refers to the address of the a. Then ptr1 or the ptr2 denotes the address of, or assigns the address of the ptr1. That is ampersand ptr, that is the address of ptr1 will be allocated, will be assigned to the ptr2. So that means only one variable, address of that will be assigned to ptr1, and the address of the pointer that already contains the address of the a, that will be stored in the ptr2, because ptr pointer is also a variable that has some memory location, that has some address in the memory. So that address, that memory, or that memory location will be stored in the ptr2. Now there is a cout for displaying on the screen, that is the address of a, that is the address will be printed, because address of a will be stored in the ptr, so this will be printed like ptr1. Then cout the address of ptr1. So this is also used to denote the address of the ptr1, there is a ptr2. That is, the address of ptr1 will be stored in the ptr2. Then cout, there is a /n for denoting into the next line. Then cout after incrementing the address value. So after incrementing the value, or after incrementing what is the address value, that is ptr plus equals to 2. That is the ptr plus equals to 2 means increment the values of ptr by 2, ptr1 by 2. That is, address will be incremented by 2. So whenever I say address will be incremented by 2, that means 2 plus 2, 4 bytes. Why? Because one value, variable contains 2 bytes, because it is of integer type. Int takes 2 bytes, so it is denoted, or it is occupied, or it is supplied by the two variables, or the four bytes. That is, the 2 plus 2 is 4. So after incremented, this is ptr1 plus 2. Then cout the address of a, that is ptr, that is ptr1 will be displayed. Then ptr2 plus 2, that is the address of ptr2 will be displayed by incremented. This is the ptr2. The memory location is always addressed by the operating system. That is, the memory management of the memory address is always located, or always occupied by the operating system. So it is the responsibility of operating system to give the address, or give the location in the operating system. So the output may vary, that depends on the system. So this is given, that is address of a, that is the address of a will be printed. For example, this is the address of a that will be given. Then address of ptr1, that stores the address of a only, that is this one at this location. Now after incremented, as I told you, it will be incremented by the 4 byte, that is 2 plus 2 is 4. So the address of a, this is last, at the end there is a 4. Now it will be incremented to the 8, because it will incremented by the 4 bytes. So this is 0x8 fb 6fff8, that means it will be incremented by the 4 bytes. Then the address of A, again it will be incremented, that is address of PTR1, not A. This will wrong be printed. This is the address of the PTR1, that will be at the end. There is a 6 because 2 plus 4 is 6. We can also use the void pointers, also used as a generic pointers, which refers to the variable of any data type. So there is a generic pointer that is used that refers to the variables of any data types. Before using void pointers, we must typecast the variables to the specific data types that they point to. There is a note that the pointers that are not initialized in a program that are known as the null pointers. So any pointers that are not initialized in a program, that are not given in a program, that is known as the null pointers. Pointers of any type or any data type can be assigned with one value, that is 0, that is known as the null address. So any pointer can use them, or any pointers can be assigned with only one value, that is 0, that is known as the null address. Now next is manipulation of pointers, that is how to manipulate the pointers, or if there is any operation that is occupied or that is used by using the pointers. So as discussed earlier, we can manipulate a pointer with the indirection operator. That is, with the use of indirection operator, we can manipulate the address, that is using the asterisk sign, that is the indirection operator, that we also studied in the C language. That is, this is asterisk, this is a asterisk that is used, which is also known as the dereference operator. That is a dereference operator. With this operator, we can indirectly access the data variable content. So with the use of this, the data variable content can be indirectly accessed by using the asterisk sign. The general form is there is a pointer, then there is a pointer variable. There is the asterisk, then there is a pointer variable. As we know, dereferencing a pointer allows us to get the content of the memory location that the pointer points to. So whenever we use the asterisk, that is a dereferencing operator that is used to get the contents of the memory location. After assigning address of the variable to the pointer, we may want to change the content of the variable also. So after assigning the values, we may also assign, or we may also want to change the content of the variable. Using the dereference operator, we can change the content of the memory location. So with the help of the dereference operator that is used, we are also able to change the content. We are also able to modify the contents of the memory location. Let us consider an example that is used for the manipulation. This is the best example that illustrates how to dereference a pointer variable. The value that is associated with the memory address is divided by the 2 using the dereference operator. So any value that is associated with the memory location with the memory address, that is divided by the 2 using the dereference operator. This division, or the division, if affects only the memory content and not the memory address itself. It only affects the memory content, not the memory address. Program 9.2 shows how to use the dereference operator, or how to get the, or how to use the dereference operator in the C++. So this is the example that says manipulation of pointer. That is how to manipulate the pointers. There is a IOStream, that is a hash include iostream.h. Then there is a hash include conio.h. So these are the two header files that is used. One is the IOStream, one is the conio.h. Then there is a void main. Then there is a value that is 10. A value that is, a variable that has a value 10. There is a pointer, that is pointer ptr. Then ptr is assigned, or is equals to address of a. So the address of a will be assigned to the ptr variable. So one ptr variable that assigns the address of the a. Then cout, there is a clear screen. Then there is a cout, the value of a is. So the value that is the value that contains, or the value of a that is printed, that is stored in the a variable, that is a. Then cout /n/n, that is for moving to the double lines gap of the two lines. Then there is a pointer PTR, that is equals to pointer PTR divided by 2. So whatever the address, whatever the value, whatever the address of A that will be given, that will be assigned, that is denoted by the ampersand, and there is a asterisk that is used to cancel out the asterisk and the ampersand. Then there is a C out, then it will be printed the value of A is pointer PTR. Then the C out next that is in the 2 line. So whatever the value, first of all it has a value 10. Then this will be printed 10. Then the value will be denoted, or value will be divided by the 2. That means the value now becomes 5, because 10 divided by 2 is 5. The value of A is 5. So that means whenever we use the asterisk sign that we used in the C also, this asterisk and there is a ampersand A. Whenever this is a PTR value that has a value ampersand A, now there is a ampersand A, that is a ampersand means address of operator. This address of operator and the dereference operators are cancel with each other. For example, that is like we studied in the math, that the two elements are cancelled with each other. So in the same way, these are the two values that is cancelled with each other, that is used, or that is used in this one, that is PTR, that is ampersand, or that is the address of operator, and the dereference operator that are cancelled out with each other. Only the value, that is 10, is available. So whenever we divide the 10 by 2, that means 5. So the 5 will be printed as it is. So before dereferencing a pointer, it is essential to assign a value to the pointer. If we attempt to dereference an uninitialized pointer, it will cause runtime error by referencing or by referring to any other location in the memory. Now, next is pointer expressions and pointer arithmetic. That is how to use the pointer expressions, or how to use, or how to done the pointer arithmetic. This I'm not taking right now. I'm taking this in the next class, that is in the Monday's class. Listen carefully. There is no class tomorrow. Now your class will be on Monday. Due to some urgent work, due to some technical reasons, I'm not taking to class. I will not take the class tomorrow. So now your class will be on Monday only. So let's take a break right now, then move to the practical part. After a break there is a class, no issues, no doubts. So after the break, let's take a practical part, then move to the practical part. So let's take a break right now. So now let's start the session again. So come back from the break. Now let's start the session again. So now moves to the practical part, that is in the last class we have discussed, that is how to use the constructor, that is constructors in the derived class. So let's move to the practical part. So now, first of all, there is a hash include iostream.h, then hash include conio.h, then there is a class, then there is a alpha, right, then there is a curly braces that is closed, that is int x, then in public it is used as an alpha, then in bracket it is int I, that is when we can say the constructor will be declared. So this is the alpha. So first of all denote this one, that is this is the constructors in the derived class. This is the how to use the constructors in derived class. Then there is a alpha that will be used. Then in this there is a definition, that is x equals to I, that is the I value will be assigned to the x. Then C out, simply it is says then alpha initialized, then there is the n, then there is a semicolon, then this will be closed, then there is a void show, one variable one member function more, then there is a show x, then there is a void, then there is a closing curly braces, sorry, opening curly braces, then see out, the x value will be printed, that is x in double quotes, x equals to, then x, this is not capital X, this is small x, then again in for moving to the next line, that is slash n, then there is a semicolon, then this is the closing of this one, then this is the closing of this class, right? So one class alpha will be declared like this one. In the same way, there is a class beta, again there is a class beta, again there is a curly braces that is used, then there is a float, y, right? Then there is a public, in a public part there is a beta, then there is a float j, then y equals to j. Now see out, in the same way it is mentioned that there is a beta that is initialized, then there is a slash n, then beta is also covered, then there is a void show underscore y, then there is a void, that is a void, then again there is a curly braces that is used, that is simply used to show or display the y value, then it is displayed y equals to, then there is a y, then there is a double slash, there is a slash n, then there is a closing curly braces, then there is a opening curly braces, then there is a class that is known as the gamma, then it is a derived class that is derived from both the classes, that is beta and the alpha. Then there are two variables that is declared, then there is a public, then there is a gamma, in bracket it is mentioned that is int a, float b, int c, int d, that is gamma is used, then there is a alpha that contains a, that is alpha is initialized, in the same way there is a beta that is b. There is a curly braces that is used to give the gamma and the, or to give the definition of the constructor, that is c is assigned to the m and d is assigned to the n, right? Then there is a c out, then gamma initialized, that is also displayed in the next line, right? The gamma will be initialized, and this is a, there is a closing of this one, that is a closing of this part, Then there is a next function, that is a void show mn function, that is displaying both the values, that is a show mn. Then again there is a void, again there is a curly braces, then cout, this will be displayed like this one, m equals to, then again double slash, then what is the value of m, that will display like this one, and then cout, that is n equals to, then n, that is it is moving to the next line, that is n, then this will be the closing of this one, and there is a class that is also closed over here, right. Then there is a int main, then again there is a closing opening curly braces, then there is a gamma, that is the gamma will be used and declaring one variable of gamma, that is gamma g. In brackets there are some values, that is 5, 10, 7.5, 20, then 30. So these are the few values. Then cout, then there is a slash n, then g dot show x, then g dot show y, then g dot show mn, right. Then there is a return 0, then again there is a closing of this one, and before this we can also put the get ch for displaying the function. There is a clear screen for clearing the screen. There are 10 errors in this program. Wow. There is a spelling that is mistake in the iOS team. Now if I compile, there are 4 errors. Believe, only 6 errors from the header files only. This is C language. Parameters or names are used only with the function body. So these are the functions that is used with the initialization part, that is how to initialize the product or how to give the products. So there is a mistake. This is not this one, this is this one. Now if I compile, there is only one error. Could not find a match for gamma. This is cannot find a match for gamma, that is a G product. That is could not find the match, that means could not find the value that is given by the gamma, because it is int main, there is a gamma that is used, this is a gamma that is used, there are multiple values. Now there is a different value that is assigned, that is this is a value, one is a int, then oh, this is the extra value that is supplied, right. Now if I compile the code, there is no error, this is a success. If I execute this code, this will be printed like as it is, x equals to 5, y equals to 7, then 20, then 30. So these will be printed like this one. Now this is not printed, that is beta initialize and the gamma initialize. So if I want to print it, we will be put in the next line like this one. Then again there is the alpha initialize. Now if I compile this code, there will be a success. If I execute this code, this will be printed like x equals to 5, y equals to 7.5, then 20 and the 30. But these are or these values, that is the alpha and the beta, are not shown. I don't know why it is not shown. Let's see why it is not shown. That is x equals to y, then C out, then show x, that is x. Yeah, this is not shown because we are only calling the function, that is a show x, show y, show z. There is no that will be printed because we are using the int main. There is a return 0, so we are dealing with only that part only. So this is the value that is given to the 5, then 7.5, then 20 and the 30. Now let's see. First of all, the concept is, or the topic is, how to use the constructors in the derived class. That is the constructors in the derived classes, or the derived class. So first of all, there are two header files. One is the iostream.h, one is the conio.h, right? Then there is a class that name is alpha, that is a class alpha. Then there is a int x, that is a that means a variable that is declared, that is of x. Then there is a public, then alpha int I, that is alpha is the name of the member function, or we can say alpha is the name of the constructor because its name is same as the class name, so it's a constructor, that is the alpha. And there is a one argument, there is one argument that is used, that is a int I, so that is of integer type, and there is a I variable that is used. Then x equals to I, then C out, that is the I will be assigned to the x. Then there is a C out, then alpha initialize, that is initializing the alpha or initialize the alpha. Then there is a void show x, that is the x will be shown, or this function will show the x value, that is a show x. Then again there is a void, then C out x equals to, then x value, then this will be closed. So this show function will be used, or show x will be used to show the value of the x. Then there is a closing of this class, and there is a semicolon to close the class. This is the class alpha that is used. Then there is a beta class. Again there is a data member that is declared, that is of y. Then there is a public. In public there is a constructor that is defined, that is a beta. Then the argument that is passed is the float j. Then j will be assigned to the y. Then there is a cout, that is beta initialized. Then show y, that is a y value will be printed. So first of all, x value will be printed on the screen, then y value will be printed on the screen. Again that class is also closed by using the semicolon. Then there is a gamma, that is a gamma is a class that is derived from two base classes. So this is known as multiple inheritance. So it is derived from two base classes, that is a beta and the alpha. So this is public beta and the public alpha. Then again there are two variables, that is the m and the n. Then there is a public, then there is a gamma, that is the name of the constructor that is used. Then there is a int a, that is the first argument that is passed. Then there is a float b, that is the next argument that is passed. Then there is a int c, then there is a int d. So that means a is of integer type, b is of float type, c is of int type, d is of integer type, that is a int type. So there are three int values and there is one float value. Then there is a alpha a, that is alpha a means the initialization, that is the alpha will be also denoted over here. Then again the beta b. Then in this there are two c value will be assigned to the m, the d value will be assigned to the n. Then C out gamma initialize, that is how to initialize the gamma. Then there is a curly braces closed, then void show mn, that is show mn is the member function that is used, that is show mn. Then C out m equals to, that is the m will be, or m value will be printed on the screen, then the n value will be printed on the screen. Then there is a semicolon, there is a curly braces closed, and there is a semicolon. That means this gamma class will also be closed, that is a gamma. There are two classes, that is the base classes, that is the beta and the alpha. Then there is a int main, that is a main function. Then there is a gamma g, that is a gamma is the name of the constructor that is used. Then there is a g, that means g is the name of the object that is declared. And there are total 4 value that is passed. One is of integer, one is of float, and two are of integer value, that is 5, 7.5, then 20, 30. So these are the 4 values that will be assigned. Then clear screen. then C out to move to the next line, then G dot show X, that is a calling the function or using the function member function, use the dot operator, that is a show X. Then in the next line there is a show Y, then show MN, then get CH, then there is a return 0. So this will be used whenever there is a get show X will be used, then the direct it will move to the show X, that is displaying the values of the X. Then when it is moved to the show Y, it is directly moves to Y. When it is show moves to the show MN, then the M and the N value will be initialized. So this is the program that shows how to use the constructors in the derived class. The derived class name is gamma. So this program is clear to each and everyone. This program is clear to each and everyone. So let's move to the today's class topic, that is a pointer. That is, what is a pointer? A simple program. That is, we have discussed what is a pointer, how to use the pointers, what is a array of pointers in the next class, but simply using the example of using the pointer, that is we have discussed in like PTR1 and the PTR2. So this is the example of using pointers. So there is a hash include iostream dot h, then there is a hash include conio dot h, then there is a int main, then there are variables that is declared, that is a, then there is a ptr1, then there are two asterisk, that is ptr2, then there is a clear screen, then ptr1 will be assigned or is it given to the ampersand of a, right? Then ptr2, that is also given the value, that is ampersand ptr1, right? Then cout, that will be printed, that is printed the address of a as, then again there is a double quotes, then there is a ptr1, and in the next line it is in the next it is moved to the next line, then cout the address of ptr1 is, then there is a ptr2, this is the address that is given, then cout to move to the next line, then cout that is after incrementing the address values, then ptr1 plus equals to 2, then cout or we can also denote the PTR plus equals to, this is PTR1, this is PTR2, yes, equals to 2. Then see out, now after incremented the address of A, then PTR1, then see out the address of PTR1, then PTR2. Then there is a get ch and there is a return 0. Then again, then again it is moved to this one. Now if I compile this code, there is no error. If I execute this code, so this will be the output. The address of A, the address of B, the address of C. These are the pointers variable that will be used. So after incremented, what are the values that is given? So this will be printed as it is. This will print like this one. The address of A is 0 into 8F70 FFF4. Then the address of PTR1 is 0 into 8 and then 2. Then after incrementing the address value, so whenever the address value will be incremented, then the address of A will be different. That is 4 will be assigned, or 4 will be changed to the 8. That is a 4 increment of the 4 bytes. In the same way, the 2 will be incremented to the 6. That is incremented of 4 bytes. That is, this is the rule, or this is the says that this will be incremented by the 4 bytes, and the 4 will be incremented by the 4 bytes, and the 2 will be incremented by the 4 byte, that is 6. Right. So this is the program that shows, first of all, there are two header files, that is iostream.h and the conio.h. Then there is a int main, that is the starting of the main. Then there are three variables that is declared, that int a, pointer ptr1, pointer ptr2. That is, first of all, the a variable, then pointer ptr, that is a pointer variable, that its name is pointer ptr. Then the pointer, that is a pointer of pointer, that is double ptr, double pointer ptr. That is, ptr is a pointer variable, also a pointer variable that points to some another variable, or that points the address of some another variable, that is pointer ptr2. Then clear screen, then ptr1 equals to ampersand a, that is the address of a will be assigned to the ptr1. Then address of ptr1 will be assigned to the ptr2. Then see out the address of a, that is the address of a will be printed, then ptr1. Then the address of ptr1, that is the ptr2. So this is the address of a that will be stored in the ptr1. The address of ptr1 will be stored in the ptr2. Then see out for the next line, changing to the next line. Then see out, it is saying after incrementing the address value. So after initializing or after incrementing the values, what will be the value? So how it is incremented? So this is a cout that is used for incrementing the values. And then there is the address of a. So the address of a will be printed like this one. First of all, this will be incremented. How this will be incremented? That is plus equals to 2, or we can say it will be incremented by the two values. That means two values means the 4 bytes. Why? Because integer takes 2 bytes. So there are increment of 1 1, that is an integer, that is a addition of the 4 bytes. Then ptr2 plus equals to 2, that means addition of 4 bytes, because int takes 2 bytes. So there are 2 bytes, that is a 4 bytes, that is 2 bytes each, that is a 4 bytes. That is, next the address of a, so that is the address of a will be printed, that is ptr1. Then address of ptr1, that is a ptr2. Then there is a get ch, then there is a return 0. So this is the case how it will be used. So first of all, ampersand a ptr1, then the address will be printed. Then after incremented, the address will be printed by 2 bytes or by the two values, that means the 4 byte, that is 2 plus 2 is 4. Then there is a return 0. So if I compile this, if I save this file, that is a pointer in C++, right? So this is a pointer of object-oriented program. So this program is clear to each and everyone. So this program is clear to each and everyone. Yeah, this program is clear to each and everyone. So I'm finishing this class right now only because I have to go somewhere. So let's finish this class, and in the tomorrow, yeah, there is one important announcement. There is no class tomorrow. The class will be on Monday only. So there is no class, or there will be no class tomorrow. The class will be on Monday only. Now your class will be on Monday. There is no class on Friday, and Saturday, Sunday is a weekend. So now class will be on Monday. That is your 11th. So there is no class for 8th, 9th and the 10th. Now the class will be on 11th of May 2015. So that's all for today's session. If there is any doubts, any confusion, you can ask from me in a practical part, in a theory part. In the next class, I will be taking your next topic, that is how to manipulate the pointer, that is how to use the pointers or how to assign the values to the pointer, that is a pointer expressions and the pointer arithmetic. That is the next part. So that's all for today's session. Thank you so much everyone for listening me. So we will meet on Monday. Bye bye everyone.